Okay.
I can't do it because I'm not a guy, but like, Simeon, do a
Let's get into what we're going to do today here. Like I said, so recall, right, that we only have a limited number of functions whose derivative we can find, right? We can always fall back on that limit definition where it's the f of x, limit as h approaches 0 of f of x plus h minus f of x all over h, right? You can try evaluating that, but sometimes that limit is very difficult to evaluate. Or some of you might be thinking, it's always difficult to evaluate, Mr. Woodmeyer, right? But sometimes it's going to be impossible for us to evaluate easily, or with, like, algebra and stuff like that. And so we can use some of our shortcuts and stuff like that we have now. It's like the power rule, right? The derivative of a constant we know is 0, right? We have the derivative of sine now, right? Derivative of sine is cosine. Derivative of cosine, negative sine. Talked about that on Friday again. And there are proofs for those two as well, but we're not going to go through those. Okay, I'm not going to worry about those right now. And then also the derivative of e to the x is itself, e to the x. Okay, so we have a few things whose derivatives we can find. All right, but sometimes, we'll run across some other stuff that we want to take the derivative of. I mean, for example, what is the derivative? If we have like f of x equals x times, let's say, the sine of x, okay, and we want to know, okay, well then what would f prime be, right? This kind of question is unanswerable for us right now, right? Because we know how to take the derivative of x, we know how to take the derivative of sine, but we don't know how to take the derivative of the product of x and sine together, right? And you might think to yourself, oh, well, the derivative of x is 1, the derivative of sine is cosine, and so the answer here should just be cosine of x. But it's not going to quite work out that way. It doesn't quite work out that way. Okay? So let's start with, so how can we kind of develop this product rule here? Okay? Well, let's see here. So let me just kind of prove to you here, because we do know this, but maybe it's harder to match these things up. So let me give you an easier one to show that you can't just say that the derivative of this and the derivative of this, if you multiply them together, it will give you the overall derivative, right? So unlike addition, right, if this was x plus sine of x, right, we could take the derivative of this and add the derivative of this and be fine for the overall derivative here. But for the product, it's a little bit different, okay? So let's just see another example of what I'm trying to say here. Something more simple. Yeah. Mm-hmm. So let's consider f of x equal to x squared times x to the 4th. Okay, so very clearly a product here. Okay, very clearly a product. And let's find the derivative of f. Should I fit this all on here? By taking the derivative of each term and then multiplying the two answers together. So this is not the way to do it. This is not the product rule yet. I'm trying to show you something that, well, let's do what maybe we intuitively want to do, right? Just like we can do with addition and subtraction here. Maybe we can just take the derivative of this and the derivative of this and then multiply them together to get the overall derivative of this function. Maybe we can do that, right? I just kind of said here we can't, right? But let's just make sure. Let's just see, okay? So find the derivative of f by taking the derivative of each term and then multiplying the two answers together. Okay. So let's see here. So and again, x squared here. So if we have x squared, then if we take the derivative, and I'll just go ahead and write it like this, the derivative with respect to x of x squared. Okay. What is the derivative of x squared with respect to x? 2x, right? Yeah, 2x. Very good. Yeah. Uh-huh. And then what is the derivative of x to the 4th? 4x to the 3rd, right? Okay, and so we might be tempted to say, all right, if f of x equals x squared times x to the 4th, then f prime of x equals 2x times 4x cubed, or in other words, 8x to the fourth. We multiply it all together. Okay? So that's the temptation here to say this, because that's what we do with addition and subtraction, right? If we were adding these two things together, I should make that a clearer 2 here. Okay? If we were adding these two things together, right, if it was x squared plus x to the fourth, then it would be 2x plus 4x cubed, no problem, right? We have that in the problem. If it was x squared minus x to the fourth, then it would be 2x minus 4x cubed. But if we have x squared times x to the fourth, can we say that the derivative of, the derivative of x squared times the derivative of x to the fourth is the same then as the derivative of the overall thing? Okay. Well, so now let's take the derivative as we're supposed to, right? So number 2 here, just for our analysis, right? Let's go back to f of x, multiply first, then take the derivative. Okay? So you guys go ahead and do that. Go back to your original function f right here. Okay? Multiply it together first, then take the derivative. So go ahead and do that just real quick here. Take like 3 seconds and do that. Okay? Okay, so when you multiply them back together, you should get x to the 6th, right? When you multiply them together first, you get x to the 6th. And so then what will the derivative be here? 6x to the 5th. Okay, this is the actual derivative, right, of f of x. This is the actual derivative, okay? Right, why did we do that whole thing up here for? Because what was the result we got up here? We got 8x to the 4th, which does not match the 6x to the 5th. So in general, can we, if we have a product, can we take the derivative of the parts of the product and then multiply those derivatives together to get our final answer? And the answer is right, is no, okay? Which is unlike addition and subtraction. You can do that for addition and subtraction, okay? So if you're adding two things or subtracting two things, you can take their individual derivatives and then add or subtract them back together. But for a product, and we'll see later for a quotient, it's not going to quite match up, okay? So, third, the conclusion statement here, is it true that the derivative with respect to x of f of x times g of x equals f prime of x times g prime of x? And the answer we just excluded there, or concluded there, is no. Okay? For this one right here? You're saying right, exactly, it's times. It's times, yeah. So we're multiplying, we add exponents there. Okay? So, this is not true in general. It might be true in some some special cases or whatever, but it's not true in general. So what is the product rule? Well, again, there's a proof for this, and the algebra for it is, there's like one little kind of weird step you have to do for it. I'm not going to go through the proof though. If you take calculus next year, you'll see it, or in your future, your teacher might show it to you. If whoever's teaching calculus next year, if I were teaching, I would show you the proof and stuff. Mr. Goff would too and stuff, and I feel like anyone else would too potentially. But anyway, what is the product rule then? How do we take the derivative of the product of two things? Because while this we were able to simplify, we're not able to simplify like x times the sine of x, right? We can't just put that together and then take its derivative. We have a product and it will remain a product because we have two things and they don't go together when you multiply them. So how do we take their derivatives? Well, the product rule is how we take the derivative of a product we can't simplify ahead of time, or maybe we don't want to simplify ahead of time. Okay, so the derivative with respect to x of two functions, f of x times g of x. Okay, so you can see the multiplication right there. It's f times g. Okay, in the first case, right, f would be x squared, and then g would be like x to the fourth, right? Or in the very early question here. X would be like the f of x, and sine would be like the g of x here. Again, just two things that are multiplied together. What's their derivative? It's going to be f of x. Oh, thank you. Okay. F of x times g prime of x plus f prime of x times g of x. That is the product rule right there. For testing. The Misa. Sounds like something Jar Jar Binks would say. Okay. So there's the derivative. So let's see if that works here for our, function we were trying to derive right there. Okay, of course, it's not necessary to use a product rule here. You can just multiply it together, get the derivative. But let's go ahead and just try it on that because we know what the answer is supposed to be. So let's take the derivative with respect to x of x squared times x to the fourth. Okay, just like that. All right, so this will equal, all right, so this right here is like our f, and this one here is like our g. And so according to our product rule here, we need to do the original function f times the derivative of g. So the original function f is x squared times the derivative of g, which is 4x to the third. Okay, so you see that right there. There's f, there's g prime. Okay, f is just the x squared, doesn't change. X to the fourth is g. We need to multiply f by g prime, so 4x cubed, right? F times g prime. Plus then, okay, the derivative of f. Derivative of f. Yeah, you can if you want to. You can put parentheses around that. This right here, you're saying? Well, since it's a product, it's considered to be grouped together because it's all one term. But you can if you want to, but it's not necessary. And then g of x is x to the fourth. And there's our f prime, and there's our g. Okay. And so now if we simplify this, x squared times 4x cubed, 4x to the fifth. 2x times x to the fourth, 2x to the fifth, and we add them together, we get 6x to the fifth, the exact answer that we had up here. Insane, okay? So it's like, right, is that necessary here? Is that impressive here? The answer is no, right? Because we could have just multiplied these together and then taken the derivative, right? Easy peasy. But now we can take the derivative of something like, x times the sine of x. X sine x. Okay, we can take the derivative of x sine x. So it's the first, x, times the derivative of the second. What's the derivative of sine? Cosine, bless you, plus the second, sine, times the derivative of the first, which is times 1. I switched the order there, but it's the same thing. I could say 1, all right, maybe I'll do it the right order here, just so that way I don't throw. So the derivative of f, so 1, times the g, which is just sine. So we end up with x cosine x plus sine x. And there's the derivative of x times the sine of x. That's the best you can do. Yeah, that's the derivative there, using the product rule. Well, all we're just trying to find is the derivative. There's no like extra step we're trying to find. Like, we're not trying to find the value of the derivative at any point. That is the derivative. The generic kind of derivative, the general derivative. Okay? So, questions on any of that? Let's do 2 here together. Maybe I'll do one, you guys can do one or something maybe. Let's see, do I have? Yeah. Okay. So, let's see. Let's find the derivative of each. Okay, so we're going to find the derivative of each of the following. Part A. Okay. Part A, h of x equals 3x minus 2x squared times 5 plus 4x. Okay. Right. Yes. Okay. So in this case, right, if we're going to take the derivative as it's currently written, do we need to use the product rule?
Yeah.
With the way that's written, do we have to use a product rule here?
Oh, no.
So, I mean, yeah, it depends, I guess, on how you interpret my question. So let me, yeah. So the product rule is not necessary here to take the derivative, right? We could FOIL this out, right? Multiply it all out, right? Expand it out. That's choice. Or we could use the product rule here, okay? Because we have two things, this and this binomial, they're getting multiplied together. So you could use the product rule here. So it's your choice, okay? I'm going to do this one with the product rule, just because we just saw it, okay? So, but if you want to try multiplying it out, and then taking the derivative, that's your choice. I'm going to use the product rule though. So it'll be, and again, f in this case is this whole binomial right there, and then this whole binomial right here. That's going to be our g function. Okay. So it'll be f, right? So this doesn't change. 3x minus 2x squared times g prime. And what is the derivative of g going to be here? This piece. Okay, row says 1.
Wait, no, it's going to have because of the 5. And then there's going to be, wait.
What's the derivative of 5 plus 4x, folks? 4, just 4. The derivative of 5 is 0 because it's constant, and then the derivative of 4x will be 4. So we're left with just 4. Yeah. And so first times the derivative of the second, and then plus, then we'll do f prime. So now we'll do the derivative of this, which will be 3 minus 4x, and then times just that on multiplied there. Okay. And now we're going to multiply it out. So we do end up still having to distribute out some stuff here, but we can still. So 12x minus 8x squared plus, and then we can fold that out. We get 15 minus 20 but plus 12, and then minus 16x squared. Okay. So there's some like terms to combine here, right? Some like terms. So the negative 8 and negative 16, negative 24, x squared. We have 12 and 12, which is 24, minus 20, so we get plus 4x. And then 15, and that's it. Okay? And so there's our derivative.
Wow.
Okay, there's our derivative. Okay? Question? Yeah. And again, you could have multiplied h of x out, then taken the derivative. Your choice. Probably would have been easier to multiply it out first in this case, I guess, because you only had to, FOIL out once, whereas here you had to multiply this out and multiply this out. And then combine like terms. So, I don't know. Again, this is something, if you decide to take calculus, is something that you will, have to kind of figure out for yourself a little bit about, when the appropriate strategies and when do you do what first versus waiting and stuff like that. This is not all of calculus, by the way, just kind of doing these derivatives. This is kind of the lighter stuff. I mean, not that as well. Some of them are going to be kind of tricky, the derivatives and stuff. But it's the analysis part too. That is really where the fun kicks in, I would say. But that's my opinion, because I like teaching calculus. So anyway, let's look at one more here. Okay, y equals 3x squared e to the x plus the sine of x minus 3. Okay? And I'm going to let you guys try this one here. Okay, at least give you a chance to start it, okay? So, And letter B, are we going to have to use the product rule? Do we have a product of two things whose derivative we're trying to find? Yes. Okay. Where are we going to use the product rule here? 3x squared e to the x. Okay, that's right. You need to use the product rule there. But then the sine of x, do we need to use the product rule for sine of x? No. Do we use the product rule for taking the derivative of minus 3? No. Okay. So go ahead and try and take the derivative of that. Okay. Try and take the derivative of that. And I will do the same. So give it a try. Remember that the derivative of e to the x is e to the x. That's right. We got to use the product rule then. Uh-huh. Oh, I see what you're saying. If it's 2e to the x, since it's just a coefficient, then you can just say the derivative of 2e to the x is 2e to the x. But the derivative of 3x squared e to the x will not be 6x e to the x. Because you got the x squared in the other one, yeah. Yeah, I'd say, I mean, you take the derivative, use the product rule for the first chunk there, this chunk. Yeah. And then add the derivative of this, and then subtract the derivative of that. You can break it up over addition and subtraction. Anyone think they got it so far? I'll come around and take a look. Really long face. Yeah, it looks good. Yep, that's right. Okay, fair enough. Yeah, that's good. Yeah, that's fine. I mean, and again, the parentheses here, you can drop them too if you want to, because there's nothing in front or behind to distribute, so you can drop them too for what you have in front. Yes, sir. Oh, so are these things being multiplied? No. So it's not a product rule of this and this. Where is the multiplication happening? It's just right there. So the product rule is these two times this thing. Okay? It's like no. 3x squared and e to the x. Sorry. So then for the rest of this, since it's got again, wherever you're separated by addition or subtraction, you can kind of treat it as a separate thing. You separate it out for yourself. So just use the product rule just here, and then add the derivative of this, and then subtract the derivative of that. So you got the answer that you got. Okie dokie? So your derivative is 0. You think you got the answer? You're still working? Okay. Yes. So remember for the product rule. For the product rule here. Actually, I'm just going to use f and g. The derivative with respect to x of f times g is going to be like that. Okay, so your pieces there. For the first one, f is going to fall into the 3x squared, or 3x squared falls into f, and then the e to the x is the g. So then fill in the rest of the spots there. Okay. Anyone else want me to take a look at theirs? Did I? Yes. Okay. Yes. Oh, I see what you're saying. You did it separately here, and then you did this. Okay. Yeah, fine. That looks good. Yeah. Which, I mean, I hear what you're saying, the exact same thing. Shouldn't always surprise us, because remember that e to the x's derivative is itself, and in this case, since, for the first part of the product rule, you don't take the derivative of this, you just take the derivative of that, but it's itself. So it gives you the same thing, and then it's other stuff too. Okay. Should have gotten something like this. Something like this. Why is it itself again? Well, again, so remember the derivative of e to the x is e to the x. So when we go to use our product rule here, right, e to the x is like our g. And so it doesn't change.
So our g inverse.
And then when we do take the derivative of g in the second part of the product rule here, derivative of e to the x is e to the x. Oh, sorry, the derivative of e to the x is e to the x there. And then, well, sorry, e to the x stays the same for the part. Sorry, no, the 3x squared is 6.
But it does stay the same.
Yeah, so okay, of course the derivative of sine is cosine, derivative of minus 3 is, well, 0. Let's go. Okay? Sure?
How do you know I mean, obviously, clear sine, the derivative sine is
How do we know that is the case? So, I mean, there is a proof for it. It's something we went over on Friday. The derivative of sine is cosine. That's one of the rules, yeah. And then the derivative of cosine is negative sine. And so those are the only ones we need to worry about for right now. Okay? So, all right. Let's do the quotient rule then. Quotient rule. You good? Good. Perfect. Just in time. So now we're going to learn something new and confuse you some more. All right. Quotient rule. Okay, the quotient rule. Okay, so again, consider f of x equal to x to the 6 divided by x squared. Okay, consider f of x equal to x to the 6 divided by x squared. Okay. Try finding f prime by differentiating the top and bottom. I'm not going to use numerator and denominator because I'm lazy. Okay. Try finding f prime by differentiating the top and bottom, okay, and dividing the results. I don't think I have my thermometer in here. No, I think I took it back to my apartment. It does feel cool. You can put your jacket back on if you want. No judgment.
That's like the size of a bag.
Oh, I gotcha. You'll feel very bulky.
Yeah.
Gotcha.
I feel like a bag.
Feel like a bag. Is it a warm bag? Because sometimes that's okay, you know. All right, so the derivative of x to the 6th is 6x to the 5th. The derivative of x squared, 2x. And so does f prime of x equal 6x to the 5th divided by 2x, right? Can we, and like we were trying to do in the product rule, that like we can do when we add or subtract, like when we add and subtract, when we have sum or difference, right? We can take the derivative of individual pieces and then re-add them or subtract them back together. Can we do it here for the quotient? And you guys probably, probably not, right? Because we're talking about a quotient rule. We just did the product rule thing and it didn't work, right? But let's just check. How could we simplify this function ahead of time before we take the derivative? How do you simplify x to the 6th divided by x squared? What does this simplify to be? Yeah, x to the 4th, right? So x to the 4th is what our function really is. And what's the derivative of x to the 4th? 4x to the 3rd. Okay, now this derivative here, or this thing does simplify some, right? 2 divided by 6 gives us 3. X to the 5th divided by x gives us x to the 4th. But are these two things the same? The answer is no, right? So, unfortunately, if we answer the question, does the derivative with respect to x of f of x divided by g of x, okay? Does the derivative of f of x divided by g of x equal f prime of x over g prime of x? And the answer is no, not in general. Okay, that's why there's a quotient rule. Exactly right. So what is the quotient rule? What is the quotient rule? Okay, it is the derivative with respect to x, again, of f of x over g of x. So there's our quotient, right? A function divided by a function. All right, here we go. G of x times f prime of x. So the bottom times the derivative of the top. Okay? The bottom function times the derivative of the top function minus the top function times the derivative of the bottom. Okay? It's kind of reminiscent of the product rule, right? In the product rule, we take, one thing multiplied by the derivative of the other, and then we add the other thing times the derivative of the first. All right? So we're doing something similar here. And so it's a subtraction. Okay? We're not done yet, though. All over the bottom squared. Okay, and there's where it's a little bit different. Okay. And so this is a little bit trickier kind of formula or format to memorize. Okay, so there's like Mr. Goff called it his calculus yodel or whatever. Okay, but the idea is, and I think it's because that's what his calculus teacher called it. But if you refer to the bottom function as low and the top function as the high function, okay, low and then high, right? High is on top, low is on the bottom, right? You can remember it with low d high minus high d low over the square of what's below. Yeah. Yes. Low d high minus high d low over the square of what's below.
Oh, that's cute.
It sounds like something like a mathematical leprechaun would say.
Indeed.
So anyway, low d high minus high d low over the square of what's below. So I'm what? Lil Wid. That's my rapper name. Yeah.
Oh my gosh, it's actually so good.
Yeah.
Like Lil Wayne. Yeah.
Exactly. But less exciting. Less exciting life. And I'm okay with that.
It's like that teacher that had a rap to come back a Jake Paul. That's Mr. Wayne.
Okay, so what can we do now? Well, I don't know. I feel like it'd be more appropriate to picture me as like dressed in a leprechaun suit and singing this as like a limerick kind of thing, than like a rapper trying to rap it, kind of thing. But anyway, that's more of an appropriate fit for me. A fantastical small creature. A small fantastical creature. With a pot of gold and a beard. Okay, so let's put it to the test here. Let's try our function. F of x equals 5x minus 2 over x squared plus 1. All right? So the derivative of f will be low. So low is x squared plus 1. D high. I mean, D stands for derivative, right? D high. So what's the derivative of the numerator going to be?
It's gonna be 5.
Are we all okay with that? Just 5?
Yep.
Yeah, it is just 5. So low D high minus high, 5x minus 6, 5 minus 2. D low. What's the derivative of the bottom going to be? Yeah, 2x. Okay, derivative of x squared plus 1, 2x. All over the square of what's below. X squared plus 1 quantity squared.
So it's gonna be
There's the derivative. We can simplify it.
4.
So I'll distribute the 5. We get 5x squared plus 5 minus, and then the minus will distribute to both terms here. So it's going to be minus 5x plus 2, and then I'll also distribute the 2x as well. So we're really going to get negative 10x here squared, negative 10x squared, and then plus 2 times 2, so plus 4x. Okay, and so then what we'll do is we will combine like terms in the numerator. If you want to expand out the denominator, you can. I'm not going to expand out the denominator.
X squared plus 9.
Yep, negative 5x squared plus 4x plus 5. Yeah, I'm going off.
Oh wait, it's 4x.
Yeah.
Wow.
That's okay. All over x squared plus 1 quantity squared. Okay.
That's it? That's all we gotta do?
And yeah, that's it. Question? You're good? Okay. So there's our final answer. Yeah, so again, this minus sign here in front of the parentheses, it distributes both to the 5x and the 2, the minus 2. So we end up with a negative 5x and a positive 2, and then you distribute the 2x as well. So we simultaneously distribute the minus and the 2x. So we get a negative 10x squared plus 4x like that. Okay. So there's an example of that. Okay. Well, we'll get some practice here for you. Okay. So in fact, let me give you guys one to try here on your own. And that's fine. I get that. This is, stretching you. No, but still, I will say, I know it is stretching some of us beyond what we, even want to do, and that's, you do have that choice with the, at this point in your math career. You can choose kind of how much you want to stretch yourself, at least what classes you select, Yeah, at Maryland, I know we had like an engineering, and like a calculus for engineers, and we had a calculus for like business majors. There were like 2 levels of the calculus, but yes, even like the business majors had to take calculus. English major, probably not, but you probably have to take some sort of math, unless you can pass out. It might depend on if you, I don't know, they might have other kind of things you can do, but. Okay. So. At first glance, right, this may not seem like, wait a minute, Mr. Wade, you said we're going to practice taking a derivative using the quotient rule here. But this does not say take the derivative, right? Or does it, right? Do you recognize the format of this limit?
Yeah, it's a difference.
It's a difference quotient, right? Okay, so this first part right here, for those of you watching at home, right? The first part right here, that's our f of x plus h. Minus, and there's our f of x all over h. So what is the function whose derivative we're trying to find? E to the x over x. Okay, so go ahead. That's the derivative you're trying to find. So go ahead, find that derivative, right? That's what you got to do. So you don't have to evaluate that limit. Pull out the necessary piece of information there. What is the function? Take its derivative. Okay, take its derivative. You are not expected, when you see something like this, okay, you're not expected to actually evaluate that limit anymore. You're expected to pull out the information that you need. Okay, so go ahead and give it a try. And then, now that I've said that piece, I want to throw in one more here too. So I'll just put this as letter C. Right down here, I'll squeeze it in. Limit is h approach to 0 of okay, so you try B and C there. Okay, give it a go. Yes.
Kind of like the d well for x, isn't it just 1 then?
Yeah, one. Yeah, very important that it's 1 and not like 0 or something like that, because otherwise it would fine. Yeah, it would be bad. So the function, the derivative you're trying to find is this. So it should be all over the bottom square. The bottom is this. So it'll be x squared, not the h.
So wait, what does the h have to do with that? Is that the main problem?
What does the h have to do?
Yeah.
The h is part of the definition of the derivative. remember, what is the function whose derivative we're trying to find? It is, there's the function right there. So when you see this format is telling you take the derivative of the function in this format. What is the function? It's this thing. So really you just pull that piece of information out. This is the thing whose derivative you take.
So I have at the top right, I'm gonna shift over x squared.
Yes. Question. Yes, it's not, yeah, so in this case, okay, what this is asking, because, so, in this case we had x's, so it's x plus h, x plus h, x, okay, and then h there, okay, in this case, you have an x's. What's replacing the x's? Oh, thank you, appreciate it. Pi's, okay, so what this is asking here is still take the derivative of the function x over cosine x, but evaluated at pi. Okay? So the pi's are replacing the x's because this is still saying take the derivative of this function, but find the value at pi. So you want to hold off on plugging in the pi's as you see. The function here is actually x over cosine x. Take its derivative, evaluate it at pi. Because this is simultaneously saying take the derivative and evaluate it at pi all at once. That's what this would find. So you want to leave x in there, then plug in for the pi afterwards. That's the idea. I'm trying to see if I can upload the product rule stuff here.
You should be Jesus. What I heard.
I don't know how to say this. I'm so It is so
All right, this is. Well, it worked for a while and it was good. Not anymore. Ah well. Okay. Okay, first derivative should be something like this. X e to the x minus e to the x all over x squared. Okay. If you simplify it, You could factor out e to the x there in the numerator if you really want to. Not a bad idea to be able to see that, right? So you could have e to the x times the quantity x minus 1 all over x squared. You could factor out these e to the x's. Not necessary, okay? But it's good that you recognize that if you did see it. All right, here, this limit is asking the derivative again, but it's asking more than just what is the derivative, right? More than what this is, because you'll see here all the x's, there are no x's here. All the x's have been replaced by pi. So when you replace your x's with a number in these limit definitions of the derivative here, what this is saying is find the derivative of the function, then evaluate it at pi in this case, because the x is replaced with pi. So what is the original function? The original function here is f of x equals x over cosine x. Okay? We then take the derivative. So derivative of cosine is negative sine, so it's going to be plus x sine x. All over the bottom squared. And then you plug in pi for your x. And so cosine of pi is negative 1. And then x is pi. Sine of pi is 0 all over. And then cosine of pi is negative 1, but it's going to be squared. So we have negative 1 plus 0 over, well, negative 1 squared, so we get negative 1. Okay, as our final answer there, when you simplify it. Good job. That's good. You got the first one right. Okay. Second one is.
I think I'm just talking to you guys.
Sure, but I wouldn't see this be 0.
So the idea here is, I see what you're saying. You're looking at this and you're saying, Mr. Wade, pi over cosine pi, it's in the place of where the function is, right? And then you're saying, okay, it's a constant because the constant here of the function is a constant, pi divided by cosine pi. So the derivative of that should be 0. What we have to remember though is that the formatting of this, okay, the formatting of this is to take the derivative of this thing, okay, right? But then the x is replaced with pi, and so the formatting of this says take the derivative of this function, but x is replaced with pi, and so. I mean, how can I describe that? I see what you're saying.
You just have to evaluate it because
If you think, if you think back to like what this thing really is, right? This is the slope formula, right? It's where we're bringing that point closer and closer and closer in to our function, or we're bringing those 2 points, the secant slope, closer and closer and closer together, so that we can make that tangent slope. Okay, and so. The idea is here we're still going to find, some sort of value here. The derivative of a constant function looks something like this. If I can just show you, it's like 2 minus 2 over, h. Because there's your constant minus your constant, right? If your function's 2, well, f of x plus h then is still going to be 2, and so you have the 2 minus 2 divided by h there. But then I see what you're saying. I feel like I'm not doing a very good job explaining that, though.
So if you just see like for the business, should you just use the quotient rule? Should you take or?
No, what I'll say, I mean, when you see the limit definition of derivative like this and the difference quotient, okay, you must take the derivative of something, and the function is right here. When the x is replaced further with a value. This is really saying take the derivative and then evaluate it at whatever value is replacing the x. That is what this is saying. Okay? I can't do a better job explaining it than that right now. But that is what's being explained there. That's what's being shown. Right? Remember, we did something kind of like this when we first talked about doing the limit definition of the derivative. Finding the derivative out of points, right? This is finding the derivative out of points. Yeah. It'll make more. I think it's because I'm skipping stuff for you guys. We're kind of jumping over some things here that maybe doesn't make as much sense as it would in like your actual classes you'll take if you do take it next year. So that's what I have to say about that. Okay. Okay. So for some practice here, I'm going to post a Google Classroom